So in this video, we're going to be learning about the double angle formulae. And yeah, if you take a look at, so these are the double angle formulas for sine, cosine, and tangent. And if you take a look at these formulas, you can see that what these formulas are used for is that if you know the exact sine, cosine, or tangent value of a certain angle, then you can use these equations. You can use either of these equations to find the exact sine, cosine, and tangent value of double that angle. So that's why it's called the double angle formulae. So yeah, that's what the double angle formulas are used for, and it's pretty straightforward in how you can use these. So like you can, if you want to find the sine of 60 degrees, like 2 times 30, then like you can just plug them in. Like yeah, it's pretty straightforward how you can use these double angle formulas. So in this video, we're just going to be proving these formulas using the compound angle formulae that we learned in the previous videos. So yeah, let's try proving this equation first, the sine double angle formula. So firstly, the compound angle formula for the sine of x plus y is sine of x times cosine of y plus cosine of x times sine of y. Nice. I hope you remember that. If you don't remember, just go back to the previous video. And let's say that x and y are equal to each other. They're the same angles. So we can just put y as x as well. So because they're the same, so we just put both of them as x. And so this will be sine of x. Oops, let's write that a bit neater. Sine of x times cosine of x plus cosine of x times sine of x. And then this simplifies to sine of 2x. Oh wait, sine of 2x, because x plus x is 2x. And we see that sine x times cosine x is the same as cosine x times sine of x. So this is just equal to 2 times sine of x times cosine of x. Nice. We just proved the first one. We just proved the double angle formula for sine. There you go. And now let's prove the double angle formula for cosine. So here we started with the compound angle formula to get to the double angle formula for sine. So same for cosine, we're gonna start with one of its compound angle formulas, and we're gonna use this one. So if you remember this is cosine of x times cosine of y minus the sine of x times the sine of y. There you go. And let's say this time again, let's say x and y are the same, so we're going to put both of them as x. So cosine of x plus x, because we put y as x because they're the same, equals cosine of x times cosine of x minus sine of x times sine of x. Oh no, what is that? Sorry about that. Sine of x. There you go. And we can reduce this to cosine of 2x is equal to cosine squared x minus sine squared x. So we got an expression, but it's not the same as the expressions over here. So what's the difference? So how does this link to that? So we can express this in two ways. So firstly, we know that sine squared x plus cosine squared x is equal to 1, according to the unit circle. So we can express sine squared x as 1 minus cosine squared x. So here, cosine squared x is just cosine squared x, and just write this as 1 minus cosine squared x. And then we can put this in terms of cosine squared x by getting rid of the brackets and getting 2 cosine squared x minus 1. So we got one of our expressions here. Or we can express this as, so cosine squared x plus 1 plus sine squared x is equal to 1. So cosine squared x can be expressed as 1 minus sine squared x. And sine squared x is just going to be sine squared x. And this can be simplified to 1 minus 2 sine squared x. And yeah, we got it here. So we just proved both expressions for the double angle formula for cosine. So yeah, the compound angle formula is coming pretty useful, and so improving these double angle formulas. So let's move on to proving the double angle formula for the tangent. But we need some space, so let's erase this first. Yeah. Okay. So actually, I'm gonna leave that on because I want you to try this out yourself. So using the compound angle formula, try proving the double angle formula for tangent yourself. So I recommend you to pause this video and yeah, try proving this formula using the compound angle formula for a tangent. And you're back. So yeah, I hope you refer to these proofs to kind of find to prove the double angle formula for tangent, because it's in a pretty similar way. So yeah, let's erase this now. And we're going to prove the double angle formula for tangent. So firstly, the compound angle formula for tangent of x plus y is equal to, let's recap our memory, tangent x plus, what is wrong with my pen, tangent y over 1 minus tangent x tangent y. There you go. And let's say again x and y are the same, so we're going to put both of them as x. The tangent of x plus x is equal to tangent of x plus tangent of x over 1 minus tangent of x times tangent of x. So this will bring us to tangent of 2x is equal to 2 times tangent x. It's over 1 minus tangent squared x. So there you go. We just proved the double angle formula for tangent as well. So in this video, we proved all the double angle formulae using our compound angle formulas. And yeah, if you're wondering if we're solving any problems using these formulas, well, later on we're going to be solving a problem using all the trigonometric identities we learn in these videos. So yeah, hope you got a clear understanding of what the double angle formula is, and hope you understood its proofs. And yeah, it's pretty straightforward how and why is used. So I hope you get it. And yeah, hope you just enjoyed this video, and see you in the next video.